All right, strap in, everybody. We're about to take a deep dive into some seriously unconventional thinking.
Sounds intriguing. Let's hear it.
Today, we're tackling the theories of, you guessed it, actor Terrence Howard.
Really? Interesting choice.
Yeah, this isn't about his acting, though. We're going deep into his ideas about, well, pretty much everything. Physics, math, the universe, even ancient astronauts.
Okay, so where are we getting all this from?
Our main source is his appearance on the Joe Rogan Experience. It's a long interview, pretty free-flowing, and let me tell you, Howard doesn't hold back.
Sounds like quite a ride.
It is. So what we're going to do today, we're not saying any of this is, scientifically proven or anything,
Of course, of course.
but we did find some seriously intriguing nuggets in there.
Definitely.
So we're going to sift through those, see if we can distill some key takeaways.
And maybe spark some new ways of thinking about the world, even if we don't agree with everything.
Exactly. So to kick things off, let's start with something a little more familiar, like the periodic table.
Okay, everyone remembers that from school, right?
Yeah, that
Yeah.
chart of elements. Well, Terrence Howard claims he's actually rebuilt it,
Rebuilt it, like from scratch.
pretty much. He argues that the traditional periodic table, it's too rigid, too box-like.
I see.
He sees these deeper connections between elements.
Deeper connections? Like what?
He focuses on frequency and color.
Frequency and color. Interesting.
Yeah, he uses a spectrometer to analyze the light emitted by different elements, and he claims they have these specific color patterns, like hydrogen, carbon, silicon, cobalt. They all share this similar color signature.
So it's like they're all vibrating on a similar wavelength? Is that what he's saying?
That's the idea. He even goes as far as to assign them a tone, like a musical note.
Whoa, a tone.
He says hydrogen and carbon are both in the key of E.
The key of E. Wow.
Yeah, just at different frequencies, obviously.
Okay, that's a pretty unique way of looking at the elements.
Right. It makes you wonder if there's some kind of hidden harmony underlying the universe.
Makes you think.
But, okay, so how does he get from the periodic table to, rebuilding it with colors and tones and all that?
Well, that's where things get even more interesting. He points to this ancient symbol, the flower of life.
Oh, I've seen that before. It's that pattern of overlapping circles, right?
Exactly. And Howard believes that this symbol, it holds the key to a fundamental error in our understanding of, well, everything, really. Geometry, physics, the whole shebang.
Hold on. How does a symbol lead to an error in physics?
He believes that by focusing on those points where the circles intersect in the flower of life, humans basically invented straight lines.
Okay, what's wrong with straight lines?
Well, according to Howard, nature doesn't work in straight lines. He says everything is curved.
So you're saying all those straight lines in our buildings, our textbooks, even the way we visualize the universe, it's all just like a human construct.
That's exactly what he's arguing. He thinks this obsession with straight lines, it's led us astray.
And that skewed our understanding of geometry, and because of that, physics too, right?
Yeah, that's the idea. He thinks if we can embrace the inherent curvature of nature, that's when we unlock a whole new level of understanding.
Okay, and that's where his concept of wave conjugations comes in.
Exactly. That's what he calls the true building blocks of the universe.
Building blocks of the universe instead of, what, atoms?
Instead of atoms, instead of quarks, instead of anything we traditionally think of. He's talking about these complex shapes that emerge from the negative spaces between spheres.
So, like, the spaces around the spheres are more important than the sphere themselves.
That's the gist of it. And from these wave conjugations, he derives what he calls the 4 supersymmetrical systems. He actually built physical models of these systems.
Wait, he built actual models?
Yeah, it's hard to explain without visuals, but they involve these complex geometric shapes.
Okay, I have to admit, this is getting a little over my head. But if he's actually built physical models, that means he's really trying to, ground these ideas in the real world.
Exactly, and he doesn't stop there. He claims to have used these models to create computer simulations that, well, defy conventional physics.
Like what? Give me an example.
One example he gives is that he recreated Saturn, with its rings and everything, in a computer simulation.
Okay, that's impressive, but I'm guessing there's a catch.
There is. He says he did it without factoring in gravity.
Wait, hold on. No gravity? How does a planet even form without gravity?
That's where his linchpin configuration comes in.
Linchpin, another one of his terms.
Yeah. It's basically a system of vortexes, and he says it creates this outward, inward, outward force. And somehow, this is what creates the structure of the planet and holds the rings in place.
So is he saying gravity doesn't exist?
Not exactly. He views it as an effect of electricity, not a fundamental force.
An effect of electricity.
He uses the example of like a charged balloon attracting dust particles.
Okay, I've seen that.
He says that's an example of a strong electric force overcoming gravity.
But, okay, what about, like, the Earth orbiting the sun? Isn't that all about gravity?
He explains that with his concept of the drift.
The drift.
Yeah, he believes that planets are gradually moving away from their stars at a constant rate.
So, like, the universe is constantly expanding.
Yeah, that's the basic idea.
Yeah.
And he actually uses this drift to calculate the age of the universe.
And I'm guessing it's a lot older than what scientists currently believe.
Way older, which obviously challenges the whole Big Bang Theory as we understand it.
Okay, that's a bold claim. If planets are drifting away from their stars, wouldn't we have noticed that by now?
He argues that our current methods of measurement, they're flawed.
Flawed how?
He circles back to his whole idea about straight lines being a human construct.
Right, and he also says that we haven't properly accounted for that in our measurement.
Exactly. And he even questions whether the speed of light is truly constant.
So basically, he's saying our entire understanding of the universe could be off.
Pretty much. He thinks we're basing everything on a few fundamental errors.
Okay, so just to recap, we've got a rebuilt periodic table based on frequency and color.
Right.
We've got a universe built on curvature and these wave conjugations. And we've got a model of planetary formation that doesn't rely on gravity as we know it.
That's a lot to take in.
It is. And believe it or not, there's more.
There's more.
Oh, yeah. Remember that linchpin configuration we talked about?
The one that supposedly explains Saturn's rings?
Yeah, well, it turns out that's not just a theoretical concept. He claims to have used it to invent a new form of flight. He calls it tangential flight.
Okay, now that's something I've got to hear more about. Tangential flight, huh? It sounds like, I don't know, something out of Star Wars or something.
I know, right? But Howard's serious about this. He says it's real, a workable technology, and it's all based on that linchpin geometry he talks about.
So, okay, how's it supposed to work? Does it, like, break the laws of physics or something?
Well, based on what he said, it seems to have something to do with harnessing vortexes.
Vortexes, like little tornadoes.
Yeah, kind of. And he keeps mentioning this inward-outward force. It's all very hard to grasp.
So how do you go from vortexes to, like, actual flying machines?
Well, he's released some videos.
Videos of this tangential flight.
Yeah, they show these drones, and they're moving in ways we've never seen before. They zip around, change direction instantly, and they can even get this linked together in mid-air.
Together, like Voltron or something.
Exactly. He calls it unlimited mid-air bonding.
Okay, I gotta see these videos.
They're pretty wild. Imagine, like, swarms of these linchpin drones just flitting around, connecting and disconnecting, forming all these different shapes.
So what, like flying Legos, what would you even use that for?
He talks about using them to, clean up space debris or building structures in remote places, even mining asteroids, he mentioned that.
Mining asteroids with flying self-assembling drones. That's ambitious, to say the least.
It is. And that's not all. He's got this other invention, a propulsion system that uses water.
Wait, water? Like H2O water?
Yep. He calls it projectile technology.
And this actually works.
He claims it does. He says he's found a way to convert water into plasma, and that's what propels the projectile.
Plasma, so like superheated water, essentially.
Yeah, something like that. And he says this could revolutionize space travel.
Make it more efficient, I guess. But water in space.
Well, he says it could be extracted from asteroids or, the moon.
Right, right. Okay, so we've got flying drones and water-powered spaceships. What else?
Well, it's not all about technology with Howard. He also delves into, like, the nature of consciousness.
Consciousness, as in, like, being aware of your surroundings.
Yeah, but he takes it further. He says consciousness isn't limited to living beings. It's everywhere, permeating the entire universe.
So, like, the universe is one giant brain.
Kind of. He even mentions this thing called morphic resonance.
Morphic resonance, what's that?
It's this idea that information can be transferred between organisms without any physical connection.
Like telepathy.
Yeah, kind of. He uses the example of, like, if one rat learns a new trick, then suddenly other rats in different locations seem to learn it faster, as if the knowledge is somehow being shared.
That's interesting. But it sounds kind of far-fetched, no?
It does. But Howard believes it ties into his whole idea about the universe being one giant conscious entity. He says we're all part of it, interconnected in ways we don't even understand yet.
Okay, I can see how that connects to his other ideas about, everything being curved and interconnected, but still, that's a pretty big leap.
It is. And then there's this whole theory about aliens being involved in human evolution.
Aliens, like little green men from Mars.
Well, he doesn't go into specifics about what these aliens look like.
So what does he say about them?
He connects it back to the flower of life. He believes that hominids, early humans, were actually engineered by these advanced extraterrestrials.
Engineered, like created in a lab or something.
Well, he doesn't say exactly how it happened, but he thinks they were engineered for a specific purpose, to mine gold.
Gold. Seriously, why gold?
He questions the practicality of gold for early humans.
I mean, it's shiny, but it's not exactly useful for, like, building tools or hunting.
Right, so he wonders if our fascination with gold, which has been around for millennia, maybe that was implanted in us by these alien engineers.
So you're saying our love of bling might be an alien conspiracy?
It's definitely a provocative theory.
Mm-hmm.
And whether or not you buy into the whole alien thing, it makes you think about why we place so much value on gold.
Yeah, where did that come from? Good question.
Exactly. Howard's always challenging us to question everything, to look beyond the surface and consider possibilities that might seem crazy at first.
And I guess that's the whole point, right? Even if not all his ideas turn out to be true, it's still good to keep an open mind and explore different perspectives.
Absolutely. Okay, so we've talked about a lot of theory, but let's get back to the real world, or at least how Howard sees his theories playing out in the real world.
Yeah, it's one thing to talk about, wave conjugations and alien engineers, but does any of this actually translate into something tangible?
That's what I want to know. And this is where his inventions come in, like that tangential flight thing.
Right, tangential flight. He claims this is a real technology, something he's actually built and tested.
And it's all based on those same principles we talked about, the linchpin configuration, those vortexes.
So I guess the question is, does it actually work the way he says it does?
Well, he's released some videos showing these drones, and they're moving in ways that honestly kind of defy explanation.
I mean, we've all seen drones, right? They're pretty cool, but they have limitations. What's so different about these?
These things, they spin around their own axis, they change direction instantly. It's like they're not bound by the same laws of physics as regular aircraft.
He calls it unlimited midair bonding, right? Like they can connect and disconnect in midair.
Yeah, and they use that to, lift objects, move things around. It's pretty mind-blowing.
It does sound pretty futuristic, but okay, if it works, what could you actually use this for?
Well, he talks about using these drones for all sorts of things, like cleaning up space debris, all that junk floating around up there. It's a hazard.
Right.
He also talks about using them for construction, building structures in hard-to-reach places.
And I think he even mentioned asteroid mining.
He did. It's like he sees this as a solution to a whole bunch of problems.
It's ambitious. But okay, what about that other invention, the water propulsion system?
Oh, yeah, that one. He's really serious about that, too.
So he actually believes you can convert water into plasma and use that to propel a spacecraft.
He claims to have built a working prototype.
A prototype? That's pretty impressive, if it's true.
And he sees this being used not just for space travel, but also for things like, cleaning up the atmosphere.
Cleaning up the atmosphere with water. How's that supposed to work?
The details are a little fuzzy, but he talks about using the plasma to break down pollutants or something.
Okay, I'm not sure I understand the science behind that. But it sounds like he's trying to apply his ideas to real-world problems.
He is. And that's one of the things that makes his work so intriguing. It's not just theoretical. He's actually trying to build things to solve problems.
But here's the thing. If his ideas are so revolutionary, if he's really onto something, why isn't everyone talking about this? Why hasn't the scientific community embraced his work?
That's the million-dollar question, right? And I don't have a simple answer for that.
I mean, maybe he's just ahead of his time.
Maybe. Or maybe some of his ideas are just, too out there for the mainstream scientific community to accept.
He does blend science with philosophy and even spirituality, which can be hard for some people to swallow.
It can. But at the end of the day, I think the important thing is to keep an open mind.
Right, we don't have to agree with everything he says.
But his work is thought-provoking.
Definitely. It challenges us to look at the world in new ways.
And to consider possibilities that might seem impossible at first glance.
I think that's a good takeaway from all of this.
It is. So, as we wrap up our deep dive into the mind of Terrence Howard, remember, keep questioning, keep exploring, and keep an open mind. The truth, whatever it may be, is out there somewhere. And who knows, maybe Howard's on the right track.
Maybe he is.
Thanks for joining us.
That